Hello. This video is created by Knut Even Lunsbacken at SLB. In this video, I want to share with you how to set up a submodeling case in Olga when using a compositional tracking model and without server options. This could be handy as you have modeled the wells in one or more Olga models and want to connect them to a flowline model, for instance. The model I am demonstrating on is a very simple model, connecting one flowline to another. An illustration picture is shown here, and as I mentioned, this is a submodeling example without use of server options, and no use of signal connections either. I am simply showing how the flow connection is set up. An example with server options and signal connection is already in the sample cases that comes with Olga. The model flowline 1 is feeding flow into the model flowline 2. The flowline 1 model is modeled with a pressure boundary at the outlet, while the flowline 2 model is modeled with a mass source at the inlet, making the submodeling connection. In the illustration image, the red pressure node and the red mass source are creating the submodeling connection. Let us have a look at how this will be set up in Olga. The first model, called flowline 1, will look like this, with the boundary pressure like shown here. What is different with this pressure node is the definition of the keys: gas C mass, oil C mass, and water C mass. I will come back to the definition of the boundary. The second model, the downstream model called flowline 2, will look like this, with the mass source defined as shown here. The mass source is also defined differently with the keys: gas C mass flow, oil C mass flow, and water C mass flow. Again, I will come back to how we set this up. In addition to these two models, I have created an empty model called master model, where I have added a scheduler and definitions of the submodels. Submodel 1 is defined as flowline 1 with flowout, setting up the pressure node as the submodel connection, where you set type equal to pressure node and refer to the node name in the node field. Submodel 2 is defined as flowline 2 with flowin, setting up the mass source as the second part of the submodel connection. As I mentioned, I would come back to how we define the pressure node and the mass source when using compositional tracking. This is the main difference between a table approach and compositional tracking approach for submodeling flow connections. So, when using compositional tracking, the submodels need to be set up a certain way. In the upstream model, you need to define the pressure node with the keys: gas C mass, oil C mass, and water C mass. These values need to be defined as compositional vectors. In this example, I am using a .mfl file with 22 components and no water phase. 22 components in the fluid file will then translate into 22 values in each of the vectors. Since I have no water phase in this example, the water C mass key is defined as a vector of zeros. In the downstream model, you need to define the mass source with gas C mass flow, oil C mass flow, and water C mass flow, in a similar way to the upstream model. These keys are also vectors. To find reasonable values for gas C mass, oil C mass, water C mass, gas C mass flow, oil C mass flow, and water C mass flow, you need to run the upstream model, in this case flowline 1, single-handed, with a traditional node setup, and plot the values that I am showing in this table: CMG, CMLTHL, CMLTWT, CGG, CGHT, and CGWT. The CM values are specific mass variables to be included in the node in the upstream model, while the CG values are component mass rate variables to be included in the source in the downstream model. With a traditional node setup, I mean with a feed name and a feed mass fraction as shown here. I have included the plotting variables in the case. Let us run the model and plot those values. As we can see, the simulation runs to completion. I am then searching for CMG and selecting the variables. To extract the values I need, I like to copy the data to an Excel sheet and post-process the data manually there. It is probably many ways to do this, but I find this way fairly quick and easy. I just massage the data slightly using transpose and filter function in Excel. Please bear with me. I am almost there. And here is the data we need for CMG. As we can see, there are 22 values, one for each of the components in the .mfl file. One important thing to check before pasting the values is the order of the components. They need to be included in the same order as they are listed in the .mfl file. We can open the .mfl file and look at the order of the components. As we can see, nitrogen is the first component and CO2 is the second component. Hence, we reorder the values. The rest of the values seems fine. We can now paste them into the pressure node definition. We need to do the same for the other values. In this example, I have already pasted those values. Now, let's start Olga from the master model. As you can see, the models are starting up as a submodeling case. As you can see, setting up a compositional tracking submodel is not completely straightforward, but hopefully this video will add some assistance and easier use of submodeling together with compositional tracking. Thank you for watching the video and catch you on the next one.